Hello, and welcome to the shortest set of notes we will ever have. Today what we're going to be doing is reviewing properties of exponents. So one thing to remember is that if our bases aren't the same, and so what do we mean by base? So this is the base of our exponent. It's the base because it's on the bottom. This is a multiplier. So this also has an exponential. Its exponential is 1. But if these bases are not equal, then we cannot combine them. It's not allowed. So we have to have equal, or what we call like, bases to be able to use our properties of exponents. So let's go through those properties. So if we have like bases and we are multiplying them together, then we add our exponents. This is b to the x plus y. It doesn't matter how complicated those exponents are. What if we had 2 to the x minus 3 times 2 to the 4x plus 5? I forgot my x. Then we would just add them together. This is 2 to the x minus 3 plus 4x plus 5. We can, of course, combine like terms up there, and this would be 2 to the 5x plus 2, right? So we add if we were multiplying with like bases. So if we're dividing, what do we do? Well, division is the opposite of multiplication, right? So it makes sense that instead of adding, we're going to do the opposite. We're going to subtract exponents. And so when we do that, we subtract top minus bottom. Top minus bottom. And so this would give us b to the x minus y. Again, we can do this even if we had complicated exponents. So let's do this one, 2 to the x minus 3 divided by 2 to the 4x minus 5. Here we're going to have 2 to the x minus 3 minus this whole thing, 4x minus 5. This is kind of like rationals. We got to remember to subtract the whole thing. So this is actually 2 to the x minus 3 minus 4x plus 5. Or if we combine, we get 2 to the negative 3x plus 2. What if we have a power to a power like this? B to the x to the y. So here we only have one base, so we can pretty much always do that. So power to a power, we multiply. So this is b to the x to the y is b to the x times y. Be careful, those parentheses do matter. There's a difference between b to the x to the y and b to the x to the y. This one says that we have b to the x, and then there are y x's up here. That's what this one says. This one says that we have b to the x y times. There's a little bit of a difference in this notation of where is that y telling us how many of what do we have. And so for example, if we have x to the 2 squared, actually let's do a different one, x to the 2 cubed, that would be x to the 8th because 2 cubed is 8. And here if we have x to the 2 cubed, that would be 2 to the x to the 2 times 3, or x to the 6. So there's a little bit of difference. And so we got to remember, this is basically an order of operations things, PEMDAS, right? Here we would do parentheses, then exponents. Here there's no parentheses, so we do this exponent first. So it's an order of operations sort of quirk, right? Oh, this should have a square. So if we did this one, 2 cubed squared, that'd be 2 to the 3 times 2, or 2 to the 6. Whereas this one would be 2 to the 3 squared is 9. So we get very different numbers. 2 to the 6 is smaller than 2 to the 9th. So watch out for that. All right, so our last property, we reviewed this a couple units ago when we talked about our rationals. Negative exponents, make it 1 over e to the x. If we have a negative exponent in the denominator, It still does 1 over, realistically, 1 over b to the x. But instead of dividing, we multiply by the reciprocal, right? Or that's how we divide. Keep, change, flip. B to the x, which is really b to the x over 1, right? So it always moves it from the top to the bottom. So those are our exponents. They're going to be important.